of the Formula One. Come on down. Who better to chat to about all of these things that have been happening than you, Pat? So thank you for joining us. I'm sure they've got some great questions. We will open it to you guys towards the end to ask him any questions that you would like. But first of all, CTO for the Formula One, what a role. How did you kind of get into that, and what was your journey to get there?
Well, I've been involved in professional motorsport ever since I left university, and so 40 odd years as a competitor, most of it in Formula One. Been Chief Technical Officer at Benetton and Renault and Williams, helped start the Marussia team a while ago, and then I sort of hopped over the fence really, and sort of poacher turned gamekeeper. When Liberty Media took over the commercial rights of Formula One, they decided to have a technical capability so that we could really look into the future, see what you guys want out of the sport, see what can make it more entertaining. And I was tasked with setting up that group, which I've done. Our first sort of, well, we've done an awful lot of things, but you know, the car you've just been looking at in the video is one of them. We've been heavily involved in the circuit modifications here at Albert Park, as well as designing a lot of other circuits. So really just trying to focus on what you guys want, you know, because you're the people we're doing it for.
So now more than ever, this role is super important in 2022. How important has it been in some of those changes for this year?
Really, really important. I mean, the aerodynamic study that we did. Well, I guess if I really look at the provenance of where this all came from, in 2017, when we started on this, when Liberty Media took over, and I started setting up my group, we looked and we said, you know, what do we need for a future Formula One? What are the problems? The problems were that the teams were not financially sustainable, so we brought in the budget cap. The cars were very difficult to race against each other, so we looked into the aerodynamics. There were problems with the tyres, so we looked into that. So, yeah, you know, I think what we've been doing, it's taken a while to sort of build it to where we are for 2022, but the first couple of races I think have shown that we're getting things right. Certainly there's never been as much research gone into a set of regulations as the 2022 regulations. You know, in the past it's been left to the teams to do things, it's been sometimes shooting from the hip, and my guys sort of get fed up with me always talking about evidence-based decision making. You know, if we're going to change something, I want to see the evidence, I want to see the modelling, I want to see the physics behind it. And I think, you know, it shows that that's the right way to go about it.
Well, we have seen quite a few changes to some of the cars here this year. I heard a buzzword the other day on one of the talks, porpoising. We've seen a fair bit of that out on the Albert Park track. Tell us what the main car changes that you've seen come through this year are and what the effects that they've had.
Well, of course, you know, the major change really is the aerodynamics. It's both the most visible and it's the one that affects the performance most. So, as I sort of explained a little bit in the video, the big problem you have is that a Formula One car is a very, very aerodynamic device. Its performance comes from having this absolutely incredible aerodynamic performance. The trouble is that you develop a car, whether you're using computational fluid dynamics or a wind tunnel, you're developing it in very clean air. So you're trying to get good performance in clean air. You don't actually care what's happening to the air behind you. So the way cars have evolved, you're tending to get this very, very turbulent weight behind the cars, and therefore the car that's following it, not only was it getting bad air reaching it, but it was designed to work in clean air, so you've got a sort of double whammy really. So what we did was we took a very fundamental approach, and we were really concentrating on what the air looked like behind the car rather than the air on the car, and that was really different. And we had to evolve an awful lot of new techniques to do that. So, you know, the computational load that we were doing was enormous. I mean, if any of you guys are involved in that, we were simulating two cars racing against each other in a curve with a fully turbulent flow, and that, you know, that takes, well, in fact, if you try to run that simulation on a high-powered sort of personal computer, a single simulation would take about 42 weeks to do. So, and we were running these in about 16 hours, so it gives an idea of the sort of complexity of them. But yeah, so what we've done is we've really taken that weight, we've constrained it rather than pushing it sideways, and we've lifted it up over the top of the car that's following. And then in addition, we've got rid of those things like, you know, those very, very complex barge boards that were on the previous cars that really didn't work in turbulent air. So we've got rid of we haven't got rid of, but we've drastically reduced the turbulent air that the following car's seeing, and then we tried to design a car that will work in what's left of the turbulent air.
As a result, it's kind of touched on, they can get closer, which makes for easier overtaking, makes for more exciting racing.
Yeah, that's right. I mean, overtaking is a bit of a... People talk about overtaking a lot. To me, it's close racing is what matters. Overtaking is sort of the end of the battle. It's the battle itself that's really exciting. So we want cars that can fight against each other. If they overtake, you know, they can be overtaken again. It's that close racing that really matters, I think.
Well, you've been up close and personal with all of the teams. Which teams have had the most significant tech changes in 2022?
Well, of course, they've all had to deal with a completely new set of regulations. And as always, when you get a new set of regulations, you see a little bit of a shaking up of the order. You know, Mercedes, who've been so dominant for so many years, are struggling at the moment. Haas, you know, last year really not there, not on the pace, and now they're up there and racing. And I like to see things like that. You know, we had lots of objectives, and one of the objectives we wanted when we talk about close racing, we have always had a sort of performance gap of around 3–3.5% between the front of the grid and the back of the grid. And I really wanted to reduce that. Now we haven't quite managed to do that yet, but I think as people get used to it, we will. But what we certainly have done is we've stirred things up a little bit, and to me that's a good thing.
Now, I know you don't have a crystal ball, but if anyone can give us a bit of insight into the future and I guess some of the tech changes we might be seeing in the coming years, what can we expect from Formula One on a technical basis?
Well, I mean, I'm now focused really on the 2026 car, and I've been working on that for over a year now. And really our real drive there is sustainability. So you mentioned in the video that we've now got 10% of ethanol in the fuel. And what we're doing for 2026 is we're going to a fully sustainable fuel. Now you hear lots about biofuels, sustainable fuels, e-fuels, you know, there's a lot of buzzwords around. Some of them are perhaps not as green as they might be. And you might say, well, why is Formula One waiting till 2026 to go to a sustainable fuel? And the answer is because we're going to do it properly. So we're really developing techniques that will give us a fuel that really does not have any fossil base whatsoever. It is a fully sustainable fuel. And you know, we have a carbon footprint in Formula One of just over 250,000 tonnes CO2 equivalent. Now only 0.7% of that comes from the cars. So you might say, well, why are you concentrating on the cars? But the real thing we're doing now is we're trying to develop a fuel that will work in any engine. So not a specialist fuel for Formula One, it's what we call a drop-in fuel. It's a fuel, while being fully sustainable, you can put it in a Formula One car, you put it in your road car, and it'll work, and it will really cut the carbon footprint of the sport. So yeah, it takes a little while to do that, but that's where our real focus is. We'll have a much more efficient car in 2026. We're happy with what we've found about the following, and we can do more. You know, as always, you sort of learn as you go along, but at some point you have to put a stake in the ground and say that's the car we're having, so we can take that further. So I think a very bright future. But just going back to that fuel, you know, the great thing is that what we're developing is we're trying to leave the competition open on how this fuel is developed. You know, whether you're taking your carbon from recycling waste, whether it's direct air capture, whatever it might be, it's not just applicable to a car, a Formula One car, even a road car. It's applicable to sustainable aviation fuel and stuff like that. You know, we fly a lot of stuff coming over from Europe to places like here. We're trying to cut that carbon footprint as well. So we're very involved in the sustainable aviation fuel, sustainable all the way through the sport. You know, we want people to be proud to be a Formula One fan, and that's really important to us.
You kind of touched on my next point, is that it's the people that drive it as well. It's not just the people behind the wheels, but this has a huge footprint, and there's so many people that come here, and Formula One is what they come here for, and if you can influence from the top right down, I guess it's a movement, right? And you guys are at the forefront of it.
Yeah, absolutely. You've got to drive these things from the top, otherwise they don't happen. You know, it's no good having a politician saying, yeah, let's go carbon neutral. It's down to engineers and people like that to make it happen. So, yeah, I really believe we're putting a big contribution into this.
Well, very insightful chat, thank you. You're, like I said, the best person to get in to talk about these kind of things. The CTO of Formula One, ladies and gentlemen, and Pat Symonds, please put your hands together.
Can you describe a little bit the process of post-incident investigation that happens when an accident happens, and like the learnings that come out of it? For example, with the Roman Grosjean accident, how did you approach that? What lessons did you learn?
Okay, good question. So, what lessons are we learning from accidents? Yeah, we're very much like the aviation industry in that respect. As I'm sure you know, pretty well everything that happens on the car is recorded. We have data recorders. We actually even have a specific accident data recorder, but we're recording everything that's going on. So when an accident does happen, we fully understand it. We can measure the forces, the accelerations. We have high-speed video where the driver's head is going. You know, we can simulate everything that happens, and we can analyse it in detail. And we have a very sort of rigid procedure that's applied after an accident, which is very akin to what happens if an aircraft crashes. So we can analyse everything that's happened, we can see why it's happened, what we can do to improve it. And, you know, there's an example with the Grosjean accident, as it said in the video, you know, safer fuel tanks. Now, there was a big fire there, and it was simply because when the engine detached from the chassis, which is not a bad thing, because, you know, that's one of the ways of absorbing energy, as it sort of bent the engine mounting studs, it pulled on the fuel tank and it opened it up. So things like that matter. It also popped out one of the fuel hatches because it wasn't fixed. I guess it hadn't been designed for what actually happened. So, you know, we learn from each accident, we incorporate those changes as quickly as we can. As well as all the time, we make the cars able to withstand or absorb more energy. So 15% this year, and every few years we up that. So, you know, compared to a car of 10 years ago, these are so much safer.
Great question. Do we have another one? Two more questions.
Let's get the questions from the younger people, they're the ones that matter.
Hi, I'm Chubby. I have a question in relation to sustainability. So you talked a lot about like the fuel sustainable changes you're making, but in terms of the manufacturing cycle or the materials, have you been looking into how to make those more sustainable and part of that process?
Yeah, absolutely. I said earlier, you know, there's a fair bit of greenwashing goes on with all of these things, and I'm really into life cycle analysis, and that's what matters. So, you know, if you make a sustainable fuel, you need a lot of electricity. I don't want that electricity to come from burning coal, for example. You know, it has to be renewable electricity. In terms of materials, we're looking at some composites that are made out of hemp and things like that, so they're renewable. Within the electrical systems on the cars, because, you know, these hybrids have a lot of electrical systems in them, there are a lot of materials in there, like the cobalts and the lithiums and things like that we need to really think about. Yes, we need them for efficiency, but we need to be able to recycle them. Now, from 2023 onwards, in order to gain an entry in Formula One, you need to be able to show a certain amount of your sort of credentials of sustainability. By 2026, you will need to show an awful lot. And equally, we will have regulations that will force recycling of these rare earth materials and the metals and things like that. We're looking at carbon fibre recycling, we're looking at what we do with the tyres after we use them. We're trying to cut down the number of tyres, so, you know, we're really working hard on this. It's really important to us.
Great question, thank you. One more question? Big voice.
Why do some cars go faster than others?
Oh, huge question there.
What was that?
Why do some cars go faster than the others?
Because maybe they're better drivers, but I would say they're better engineers, because I think it's the car that matters. So what makes the performance of the car? Well, there are lots of factors, and you have to get them all right if you want to win championships and things. You need a good driver, you have to be able to use your tyres well, your aerodynamics have to be good, you need a really good pit crew, for example, when you're doing your pit stops. You need to have a good team behind you, and when you get all those things together, and that's why I've loved being in racing so much, because it's a real team sport. It's not just about one driver or one athlete of any sort. Well, those sound good, don't they? Yeah, it's a team sport, and when you get everything working together, then you're successful.
Fabulous. Well, we have to let him go. He's a very important man at a very important race today. One more time, thank you for your time. Pat Symonds, the CTO of Formula One.